Okay. Thank you very much, Mark. And let me just say that I've been interacting with national water leadership since the beginning of this year on the Open Water Data Initiative and on the National Flood Interoperability Experiment. And although Mark was describing this as a Herculean task, I want to tell you that it's been an inspiring task. You know, I'm an immigrant to America, you know. America means something to me, and I hear a lot about dysfunction in Washington, but that's not been my experience. My experience has been that there's been aspirational leadership, willingness to work together, willingness to take risks, to reach out for things that we don't have now and envisage a new future, different than the one we have now. And so my experience has been a very, very positive one, and I want to commend the leadership for that experience. And this is the top drawer here. So let me just say I'm really proud that they've all agreed to be here. Mr. Dalton, who from the Corps of Engineers was called away at the very last minute, and so Chandra Patek is going to give his presentation on his behalf. So we really appreciate Chandra doing that. So I've got a little diagram here that I made up at a conference some time ago about how I could see the connections between federal water agencies. And as I see, and this is just a sort of simplified view, but the USGS is a nation's leading water science agency, has data that supports all the others. The Weather Service deals with the atmosphere, sort of the hydrology atmosphere to the land. Once the water hits the land, the Corps of Engineers takes over and has the structures and rivers and hydraulics and so on. And then once it hits the town, then FEMA takes over and the emergency response and so on happens. And so the order of the four speakers is going to be in this order, so I've asked them to speak for 10 or 15 minutes and then we'll just open it up for a general discussion. So I'd like to begin by introducing the first speaker, Dr. Jerad Bales, and I understand he has some important announcements to make, so let me just introduce him by saying that he is the Chief Scientist for Water at the USGS, and he's been in that position since 2009. Before that, he had a long career with the USGS in North Carolina. He has a BS and MS in Civil Engineering from the University of Tennessee at Knoxville, and I'm very proud to say a PhD in Civil Engineering from the University of Texas at Austin. I remember Jerad when he was a student too. Not of mine, I have to say, yes. He worked in hydraulics. So anyway, welcome, Jerad. We really appreciate you being with us.
So this is one of my favorite slides, and so I put it up yesterday. I'm gonna put it up again today. I think it demonstrates or it illustrates the issues that we face in the water community. We have here food, the corn crop. We have energy, the tractor, and we have water. So this connection between food and energy and water is, I think, a major issue that we're facing in the water community, and sharing data is a key to addressing these issues. So I'm going to talk about four things very quickly. I'm going to talk about Integrated Water Resources Science and Services, IRIS. I'm going to talk about the genesis or the beginning of the Open Water Data Initiative and what we're currently doing. I'm going to make some announcements about the North American Water Watch and the water theme of the White House Climate Data Initiative. So we're actually rolling both of those things out here today. So IRIS, very briefly, because I think Tom will talk about that in more detail, but among three of the major, and there are about 26 or so agencies that do water in the federal government, but among the three of the principal water agencies, the Corps of Engineers, the Weather Service, and USGS, we recognized that we need to do business differently. We recognize that because of some failures that occurred, most notably during the Nashville flood, I think of 2010. And so there were some failures of communication during that event. We recognize it because we all have fewer resources. Chandra was telling me just a minute ago in his shop, They used to have 30 people doing hydrology and hydraulics at headquarters. Now they have 3 people doing that. We're all facing the same issues. And so because of these things, we got to do things differently. We got to cooperate and collaborate. Our initial focus in this IWRSS initiative, which FEMA has now joined or is about to join, our initial focus has been on flood inundation mapping, because all 3 and now 4 agencies play some key role in flood inundation mapping. We all were doing our own. Let's just do it the same way and save resources. And then the other issue was data interoperability. One of the failures of communication in the Nashville event was a failure to exchange data quickly and seamlessly. And then more recently, OSTP, the Office of Science and Technology Policy, which is in the White House or Executive Office of the President, has become interested and engaged in this. And so John Holdren, who's a science advisor to the President, said basically meeting the global water challenge means better access and exchange of data. And so that's what we're trying to do with leadership at that level. So for open water data, the vision is given here, but basically is to provide foundational water data and data services or web services to support the full range of water applications. It would include metadata. It would be built on the Federal Geospatial Platform. It would provide access to real-time data across agencies, across organizations, across NGOs. It would provide the capability to assimilate data for national modeling activities, which is one of the things that we're thinking about in IWRSS. It would provide maps, and it would provide a marketplace to engage the private sector in helping build these services. And so right now, the Open Water Data Initiative, which is kind of loosely linked to IWRSS and loosely linked to some other things, the Department of the Interior kind of took some initial steps here through the Federal Geospatial Data Consortium and said, we want you, the FGDC, to start making some steps in this initiative. We don't have any funding yet. We have some hopes of funding in future years, but let's go ahead, engage the community through the FGDC and start thinking about taking some steps toward building this open water data infrastructure. And so it would leverage the geospatial platform, which is a platform where a lot of you can go to get a lot of data, primarily geospatial data. We would engage the international community through the Open Geospatial Consortium, and we would identify existing data sets that could be enhanced and made a part or a foundational part of this open water data. So this is a kind of a nascent activity. It really just kind of kicked off this spring. The FGDC subcommittee on, or the FGDC and the ACWI, Advisory Committee on Water Information, Subcommittee on Spatial Water Data, has been meeting almost bi-weekly to start trying to push this thing. And this is ACWI and this subcommittee is not just feds, it's feds and states and the private sector. So everybody can become engaged in this. I wanted to announce today, we actually put out a press release on Tuesday, but the North American Water Watch. So hopefully all of you are familiar with the USGS Water Watch page, where you can go every day and see the status of stream flow across the country relative to historical conditions. So this has been up for a long time, 10 or 12 years. We've been working with our partners in Canada, in Environment Canada, with Quebec and with Alberta, to create the North American Water Watch now. And so we're very proud of this. It just went live, like I said, Tuesday, but it's a water watch now for all of North America. And it's a demonstration of what we can do with open water data. So this is, this is a step forward. It's a big step in international cooperation. We are working with the Mexican government as well to extend this into Mexico. So these are the kinds of things that we can do internationally, globally, as we move into this next generation of data sharing. There is a White House climate data initiative that has been underway for a couple of years. This was put forward by, again, the Executive Office of the President to begin to help the country deal with the effects of climate change. And so you may have heard of data.gov. So data.gov is a repository for all kinds of data, but it's really just, it's just kind of a catalog. You go there and you find the different data sets and you go to them. So it's not particularly modern. It's not particularly, if you know what you're looking for, you know where to go, right? I mean, if you're looking for stream flow, you go to USGS. You don't go to data.gov. If you want weather products, you go to NOAA and not to data.gov. But if you don't know what you're looking for, it's a good place to go to see what's out there. But this whole idea is to harness data analytics and big data to provide information to people that are dealing with, in this particular case, climate change. It's also to help sustain and encourage public-private partnerships. Google is involved in this. Microsoft is involved in it. A number of big companies that you recognize are involved in this initiative, and they're taking the data that are being made available on data.gov or climate.data.gov, and they're generating derivative products, that the public can use. At this point, there are themes in climate.data.gov, and at this point, 2 themes have been rolled out. One is on food and agriculture, and the other is on coastal flooding. Well, today we're rolling out the water theme of climate.data.gov. And so there's actually a press release that's being released today. I went to the page this morning, and so the water page is up. And so, you can look on USGS or other places for a press release on this. So again, we're very proud of this. The USGS, in partnership with NASA, put this together. USGS kind of did the heavy lifting on the data sets. NASA kind of did the behind the scenes, architecture, hardware for it, and supporting it that way. And so, again, if you go to climate.data.gov, you'll see the launch of the water theme, and also you'll see the mention of the AWRA meeting today where, we're announcing it. So this is on the White House web pages today. Again, it's a first step in sharing data. Right now it's a catalog with metadata. It's not seamless as we envision open water data to be, but it's a first step. There are about 125 data sets in here in the water theme of climate.data.gov, so there's all kinds of things there. So I encourage you to go look at it and give us feedback on how we're doing. And so this, so coming back around now to this open water data initiative, climate.data.gov and North American Water Watch actually fit into the overall, view or the overarching view of open water data. So this is kind of, again, as I said, it's the first step. It's a water data catalog. And so the next step or the vision is to provide this information as a service, right? So you don't have to go and grab a piece of information, but rather that information is updated continuously on this web page so that you have the latest information provided as a service there. And then next steps are to enrich the data with other kinds of tools, and I think Tom will talk about some modeling activities, and then to engage the private sector on these things. So a couple of nice things that have happened, that have already happened out of this open water data initiative, and a hope and an expectation for a lot more. So what does the future hold? This is maybe my other favorite slide. that I showed yesterday, but I really like it. So this is 2005. This is Vatican Square, I think when Pope Benedict was announced. And this is 2013, just 8 years later, when Pope Francis was announced. And, you know, what's the difference here? I mean, it's amazing. It's just amazing. It boggles my mind that 8 years later, just 8 years later, the cell phone technology and the pictures have just exploded. And so it's really hard for me to tell you what 5 years is going to look, in 5 years, what it's going to look like. But, you know, the landscape is changing, and it's changing quickly. And we're trying to take advantage of that. So thank you, and hopefully we'll be able to engage.
Okay. Thank you very much, Jerad. And please come and sit down in the seats. You know, there's quite a few people have come in since we got started here, so no need to sit at the back here. And I think you can see why I have been inspired by the interaction with the National Water Leadership that we've been having this year. It really is inspiring to me to see that the AWRA is on the White House webpage. I mean, I remember we had a breakfast, right? We sat together at breakfast here in Washington. I don't remember exactly when, but the idea of engaging the AWRA in this process occurred at that breakfast. And this is important. It's important that these initiatives are not just federal things. It's important that there be professional society engagement, and that's why the AWRA is involved, so that everyone can be involved, and it's not just, you know, something going on here in Washington. We can reach out into the country. Okay, so the next speaker in our session here is Tom Graziano. So let me bring up his presentation. Tom is the current Chief of Staff of the National Weather Service, and from 2000 to 2013 he was the Chief of the National Weather Service Hydraulic Services before he assumed his present position. He has a BS in Meteorology from Northern Illinois University, and an MS in Meteorology from Penn State, and a PhD in Atmospheric Science from North Carolina State University. So welcome, Tom.
Thank you, David. Appreciate the opportunity to be here and speak on behalf of the National Weather Service and as part of the broader IRIS consortium. As David mentioned, I was the Chief of Hydrologic Services for the National Weather Service for 13 years, so it's really nice for me to get back with the water community today. I took my current job about a year ago as Chief of Staff. I consider David very similar to the man that I work for now, Dr. Louis Uccellini, who's the director of the National Weather Service, and I consider both of them to essentially be forces of nature. And I got to see that in firsthand when we invited David down to the first meeting we ever had at the National Water Center down in Tuscaloosa, Alabama, on the campus of the University of Alabama, and we brought together all the senior leadership in our water program within NOAA, as well as Dr. Nimmich was there from FEMA. Folks representing the Corps of USGS and Corps of Engineers were there as well, and we invited some top-line academics, and so David was one of those folks. But we spent the week really getting into how we wanted to transform the program and leverage the Water Center and leverage IRIS to really provide better water resources prediction, really evolve the program, really transform it. And David could only stay for the first day, but after he gave his talk, which really wowed everybody when he showed the Rapide model and what he was been doing, he wrote an email that literally was, a multi-volume set to Don Klein, who I'm standing in for today. Don's actually the lead for water in NOAA, and about the National Flood Interoperability Experiment, NFIE, and it's really exciting because it's essentially a use case for the Open Water Data Initiative, and it's really an opportunity for the IRIS partners to work together, to work with Quasi, the academic institutions, the private sector, to pull all the data and modeling, couple all that together, and leverage the Water Center to do that, to provide enhanced capability and evaluate that. So we're really excited about that, and the seed was planted right here with David's visit to the Water Center. So with that, I want to talk a little bit about what I'll talk about today, as my title slide mentioned, is specifically about the IRIS. I'll give you a little bit of background on how that came to be and sort of what it means, I think, to all of us. And a little bit about the Water Center and how the two are intrinsically related and what the Water Center really means, or what we hope it means for water prediction in this country. So the impetus for this, and I'm sort of preaching to the choir on this, but this, these are the issues that we face, certainly population growth, agriculture, economic development, stressing water supplies, escalating socioeconomic risks. When you just look at floods alone, which we in the Weather Service, we compile data, and I think we do it conservatively, but data on flood impacts. If you look at the last 3 decades, and you normalize those dollars to 2013 dollars, what we've seen is an increase from like $4.7 million for the first of those 3 decades to 7.9, and then over $10 billion. These are all billions of dollars annually, but over $10 billion annually for the past decade. So, and again, those are normalized dollars. So you see the impacts increasing. And when you think about droughts, they're on the same order of magnitude, if not even a little bit greater. So, we certainly face significant issues. And if you look at the loss of life that we've seen in this country associated, and we've compiled these data for the past several decades, and you extrapolate forward, we can expect to lose about 3,000 more folks in the next, 20 years in this country. So it's certainly an issue, and it merits our attention, our collective attention, our collaboration to deal with these issues. So, the population growth, we've got shifting population density, a changing climate. The modeling capabilities, at least that we use within NOAA and the Weather Service, our current way of modeling is we leverage the USGS's data infrastructure, their stream gauge network. We forecast at about 4,000 points on rivers at stream gauges around the country. And we use statistically based models that are highly calibrated based upon climatology. So certainly with a changing climate, and we've all seen the papers on stationarity being dead and the past is no longer prologue, we've got to find new, better ways to forecast our rivers and water. So hence the move to more physically based approaches, the notion of development of a national water model among the IRIS partners and a potential implementation thereof at the Water Center. Jerad talked very briefly about IRIS, the Integrated Water Resource Science and Services. These are the federal partners, and it started with 3 and will very, very soon become 4 with the addition of FEMA. This all started back in discussions back in about 2007. We had a meeting. Every other year in the Weather Service, we used to have a meeting on a cold regions workshop, and we'd get together and we'd talk about issues, operational and science issues related to forecasting in our cold regions. And the meeting we had in 2007 evolved into something more. We had all the federal agencies there, at least the core and the GS, the ones that we work on a routine basis with to make the water forecast. And we came to the realization that with the issues that I showed on the last slide, that we really, as Jerad's alluded to as well, we need to, the issues we face are growing. They're becoming increasingly complex. They're multidisciplinary in nature. They're really bigger than any one of our agencies. So really, to address these issues and to address them fully, we really have to work together to do that. So born out of that meeting was this seed of an idea of forming this consortium called IRIS, Integrated Water Resources, Science and Services. And so what we did coming out of that meeting is we had a series of it was essentially 5 national meetings at NOAA headquarters, at CORE, and with the USGS to sort of lay out what are the critical issues that we want to address. And then we compiled that. Actually, Don Klein, who couldn't make it today, but Don actually put together a couple 100-page document that was based upon those meetings, and which really outlined the things that we said we wanted to do together. And interestingly enough, the 7th chapter of this document talked about a virtual or physical water center that we would all co-inhabitate, and we'd work together and leverage our resources and work in the water prediction data and water prediction game together. And that document was actually the agencies approved it. It was basically ready for dissemination in January of 2009. And then a couple of months later, with our appropriation in 2009, Senator Shelby of Alabama, there was an addition to the NOAA budget essentially for the National Water Center, for us to establish that. And there was another appropriation or our earmark, if you will, in 2010, and the combination of those resources are what we used to actually build and construct the National Water Center, which opened earlier this year. So anyway, that's basically how IRIS came to be, and through those meetings, those interactions, and then weaving in the quasi. There was a meeting in April of 2012 with members of Quasi where we laid out what we consider to be the grand challenges, looking at water security, water quality, and then looking at extreme events, floods and droughts. Okay, a 5-point strategy for IRIS. This is, I won't get into all of the details here, but just to give you some sense of what's in this roadmap that we put together for IRIS. Talk about it as an innovative partnership, essentially a new way of doing business, really reaching across each other's agencies, leveraging our resources, working together to share technology, addressing these increasingly complex multidisciplinary issues collaboratively. Enrich stakeholder participation. I'll talk a little bit in a minute about what we've done there. We have over the past couple of years worked very hard with river basin commissions around the country. Carol Collier is here, and we worked with her former commission, the Delaware. Within the last couple of years, we held a stakeholder forum there as well as in other parts of the country. And what we did is we basically surveyed a broad spectrum of stakeholders in those respective river basins. We held these forums, and then we did post-assessments, and what I'll show you is essentially, in a broad sense, what those results were. And I think they're quite illuminating. New digital information products, we've talked about that, and making these available through the Open Water Data Initiative, not just forecasting, a stage and flow at a river forecast point, but using these high-resolution national models to forecast the full water budget, taking into effect, linking with the groundwater models and really providing information at an NHD plus scale, really at a street level, because that's the scale at which the spatial scale at which decision makers need information to make the decisions that they need to make. We spent a lot of time in these forums asking people, what are the issues that keep you up at night? What information do you need to do your job better? And essentially, they need information at those sorts of scales to get it right. Improve supply and distribution. As Jerad mentioned, there's over 20 federal agencies that have some hand in water. And one of the things that we consistently hear from stakeholders is that they don't want to go to 20 some odd different places to get that information. They want a portal and integrated access to those data. And they deserve it. And so that's essentially what we're working toward. And the National Water Center is really a catalyst as we see it to make these things happen. So in terms of stakeholder engagement, again, we worked with the Hudson River Basin, the Susquehanna, the Delaware, the Potomac, the Ohio, the Russian, others. And this is just a spectrum of the types of folks that we met with and engaged at those respective forums. You can see it sort of runs the full gamut of stakeholders in our water resources community. Some of the key priorities that emerged, that distilled from these forums, basically they run the gamut as well, from flooding, water quality, availability, drought, and climate change. And they need an integrated understanding of this information. And as was mentioned at the onset of this session, Dr. Sullivan's comments about taking data and information and what is environmental intelligence? It's taking data and information predictions and integrating them into actionable intelligence, into actionable information, so people can make decisions based upon those information. And so some of the stakeholder priorities, basically a broader range of hydrology. It's not just floods, as I just showed you. We need information at time and space scales that are certainly greater than what we provide today. People are looking for total water level along the nation's coast. Our forecast right now, they get to the brackish zone and they essentially stop. We are not coupled with our coastal estuary models now. We're working forward now. Sort of the general target is to introduce or develop and implement a comprehensive water prediction capability, which couples not only our atmospheric models with a national water model, freshwater model with coastal estuary models, so that we actually, provide forecasts from summit to sea, from treetop to bedrock. So we can address the kind of issues that decision makers told us they need to see informed. Detailed characteristics of small watersheds and hill slopes. Again, the spatial scale of this information needs to increase, and consistent and coherent information across large watersheds. Key issues, not only from on the water resources side, but actually on the atmospheric side. We saw that in a recent report that was the National Academy of Public Administration just produced, and actually it was more focused on the Weather Service, but when they were looking at both our weather and water prediction services, they talked about the relative inconsistency about what, in terms of what we provide on a national level. Okay, so the National Water Center, it's located, as I mentioned, on the campus of the University of Alabama in Tuscaloosa. We had a groundbreaking ceremony back in February of 12. It's roughly 65,000 square feet. It's a LEED Gold facility. We actually assumed beneficial occupancy of the facility on Valentine's Day of this year. And the first staff showed up in April, and we had our first meeting there in May. As I mentioned, that's when we had the good fortune of interacting with David and others. The initial operating capacity, or IOC, is scheduled for May of next year. At that time, we anticipate having 5 to 10 folks from the USGS, a person or two from FEMA as well, and then roughly 25 to 30 UCAR visiting scientists, as well as 15 or so NOAA FTE. So that will basically be what will comprise IOC. The capacity of the facility is around 200 people, and what we hope to see is, our plan is to grow that and ultimately occupy the facility in full. It's basically, the facility is multi-purpose. It's, well, first of all, let me get through the vision and the mission here so you have some sense of that. The vision here is scientific excellence and innovation driving water prediction and decisions for a water-resilient nation. Okay, and our mission is, as we've really talked about here, is collaborative research, develop and deliver state-of-the-science national hydrologic analyses, forecast information data, decision support services, and guidance. Okay, this is the first time, if you know the Weather Service at all, and I don't mean to be so Weather Service specific here, but if you know the Weather Service at all, we have 9 national centers for environmental prediction. And we have the Storm Prediction Center, the National Hurricane Center, the Weather Prediction Center, the National, that helped me out here, the National Hurricane Center. I talked about Severe Storm Center, Storm Prediction Center out in Norman, Oklahoma, et cetera, et cetera. We've never had a national center that supports the water program within the National Weather Service. And if you look at the assets of the National Weather Service, only about 5% of the assets or people in the Weather Service actually are focused in some way or part on the hydrology program. So we're pretty doggone excited about, this facility and what it potentially portends for the future, especially given the framework that we've established under IRIS and the ability to get us all under one, working together, and if we can get us all under one roof, all the better in terms of evolving the program. Okay, some of the functions that are targeted for the National Water Center, we see it as a foundation for developing a national common operating picture. Jerad mentioned earlier about the significant flooding in May of 2010 in Nashville. You can go back a couple years from that. You can talk about the significant flooding in the Midwest in 2008. You can talk about significant flooding in the Southeast in 2009. We had Nashville in 2010. We had the Midwest again, the Mississippi in 2011. We had the low flow on the Mississippi in 2012. We had Sandy in 2012, which actually had a pretty big freshwater contribution. What we're seeing is really a rash of very significant hydrological events, more so than what we've seen on a more regular basis than what we've seen in the past, which really underscores the need, for us to work more collaboratively together and really develop a common operating picture. Really singing off the same song sheet in an operational status. One of the things that we've seen in service assessments that were done for all of those events is that we need to find ways to better share data and information, particularly in real time, to inform critical decisions that FEMA and other stakeholders are making. So we, again, plan to have a fully integrated water resources program, operate a national water model. There's resources in the President's FY15 budget. Once we get an appropriation, hopefully it will be there for us to develop and implement a national water model at the National Water Center, integrated data services, a data archive, and certainly verification and validation. And then we see this as really a catalyst for accelerating the R2O and O2R, really working with the broader enterprise. You see the water enterprise now essentially where the weather enterprise was maybe 20 or 30 years ago. It's relatively young in its age, and there's a tremendous opportunity for all of us to work together, both in the academic community, the private sector, and the federal sector, really to evolve our services, grow the program. In the federal sector, providing the raw materials that then can be value added, with the private sector to support the decisions that need to be made. And with that, I'll leave it there. Thank you, David.
Thanks, Tom. And those that are at the back, please feel free to come up and sit down. I mean, some more people have come since we began the session. And so Tom mentioned my going to the National Water Centre to participate in its opening meeting, and I saw the projections about the number of people that were going to be there this summer, and I thought, well, you could look on that as an opportunity, right? Where can we get some more people? Well, academia, we got students, we got faculty. So this National Flood Interoperability Experiment, we're planning to have a summer institute at the National Water Centre to bring together students and faculty from across the country to work with commercial partners and the government and envisage what the next generation of flood forecasting could look like for the nation. And to do that from the National Hydrography Dataset Plus, which has 2.6 million reaches. So Tom mentioned 4,000 forecast points now to 2.6 million. That's a factor of 600. I mean, we're not talking about 2 here, or 10, or even 100. We're talking about 600. So can we just take a leap to where the nation needs to be and then backfill it and make it solid? That's what we're trying to do with the National Flood Interoperability Experiment, and do that in 1 year. Yeah. Okay, little challenge. The next speaker is Chandra Pathak. He's going to be presenting in place of James Dalton, who has been called away, as I mentioned earlier. Chandra is an old friend, actually, I have to say. So he has a BTEC from India, from MTEC from Asian Institute of Technology in Bangkok, and a PhD in agricultural engineering from Oklahoma State University. I first got to know Chandra when he was at the South Florida Water Management District, and we worked together for quite a few years there. And then he subsequently has joined the U.S. Army Corps of Engineers headquarters staff. So welcome, Chandra. We appreciate you making this presentation.
Thank you, David. I appreciate that. So, as David said, I'm standing in here for Mr. James Dalton, who is my boss, and he couldn't be here because of some other engagement which came up last minute. So, I would be talking about the open water data assessment of national priorities. In terms of Army Corps of Engineers, you probably know this, that Army Corps of Engineers is a large organization with about 30,000 employees. 2/3, about 24,000, are working in civil works program. There are actually 2 programs, military program and civil works program. And we do have a direct line item in the budget from the Congress. We do not get funding from Army Corps of U.S. Army. However, we are under the umbrella of U.S. Army. So with that little minor information, just wanted to get you started. So I'm going to focus on mostly the challenges with respect to open water data. So we're going to talk about Army Corps of Engineers being one of the water infrastructure agency. We're going to talk about core water management system, which we use in water management. We're going to talk about partnership with IRIS. We're going to talk about open water data, and we're going to have some discussions of that later. So in terms of infrastructures, we have a set of dams, 708 in the country. We have about 2,500 levee systems, and that constitutes to be about close to 14,500 miles of levees. These 708 reservoirs we have, which we manage, we operate essentially. And the primary purpose of these are the flood risk management, which are very well known. So we are the only agency who have the mission of flood control in the federal context. We do have some operational responsibility for other federal projects. For example, Bureau of Reclamation, we do their operations during the flood seasons. So we have some of those structures in addition to 708. And they're about close to 100 structures. In terms of secondary purpose, we do have others which are listed over there. In terms of the other, we have a issue we are working on is a climate resilience infrastructure. Jerad Bales mentioned before that under the executive order, we are working to find specifically on the adaptation plan. So we are currently in the process of doing that. And probably this is not news to you that water resource infrastructure is sensitive to the changes in the climate and weather. And we are currently in plan for doing the sea level change policies, how typically the coastal structures will be looked at with respect to climate change. In addition to, we are also developed a framework for inland hydrology under the climate change scenarios. One of the major mission is water management mission, and you could see that we do have several multi-purpose reservoirs. Significant portions of our portfolio of dams have multi-purpose, but primarily the flood control. And we get into a situation where we are constantly called upon to give up flood control space in our reservoir spaces. And we are congressionally, here if you locate the word congressionally authorized, we are congressionally authorized by law to keep those flood space available flood control. So if there are any requests to make those changes, we need to go back to the Congress to get those changed. In terms of water management modernization, we have about real-time support for water management. We have 700 plus dams, as I mentioned, structures, and we need to operate them from floods to droughts and everything in between. As Gerald mentioned, that primarily most of our work effort in water management could not be done, and I should repeat this, could not be done at all without the help of National Weather Service and USGS. So they provide us the science, specifically the QPE, that's a quantitative precipitation estimate, quantitative precipitation forecast for number of days, and USGS provides us stream gauging data. For more than half the stations of 4,000 stream gauging stations, we use more than half, about 2,500 of them, and we pay for it. So under the cooperative agreement with USGS, about in the tune of about $20 million a year. Now moving on to this core of engineers, what we call core water management systems, we call it SWMS, CWMS. It is essentially a suite of software integrated a package, which is shown here, hydrology, which is using HMS as a software. Water management, we use Reston. Then we use hydraulics using HEC-RAS to convert flows into stages in a river flow. And then the last one is FIA, which is looking at the consequences. So this is done, all the watershed modeling is done here. And at the bottom, you see that data acquisition, which is a near real-time data acquisition goes in a database, information dissemination, and varieties of the the districts. We have about 44 districts within Army Corps of Engineers. 36 of them are using this in some form of other SWIM system. The differences are that all of them are not fully functional. So in terms of implementation of SWIMs, we have a role of about 212 watersheds in the United States. This implementation is done with the help of what we call a center called Mapping, Modeling, and Consequence Center, MMC. And this agency is a virtual agency. The headquarters is in Vicksburg, Mississippi, and they have about 125 people who work remotely at the different district locations, so there is no movement of people. This is a virtual organization which helps us implement SWIMs. About 50 watersheds of those, and I'll show you in a minute, the watersheds will be completed by end of the year. Our goal is to finish all 212 in next 5 to 7 years. The SWIMs is being started in 2011. The completed models we have talked about is going to be used by the local districts, which I just mentioned, 36 of them, for daily water management activities. Additionally, those models will be used for feasibility studies, emergency management, planning studies, dam and levee safety, and so on. So there's a multi-purpose use of these watersheds, modelings, in the context of, but primarily used for water management purposes, and as well as they will be continually be updated for water management. This is a map of those 212 watersheds in the country, and this shows the graphics of what watershed management we are working on those watersheds with a plan at the various levels. As I said, we plan to finish about 50 watersheds within the country. And this is a significant investment for us. It's in the tune of $125 million over last, we already invested about $25 million in the last 3 years. We have another for 5 to 7 years to go on this work effort. In terms of dissemination of data, and I think this is where we have issues, and we're going to talk about in a minute about that. So we have the SWIMS data dissemination tool, and presently this information is being put together along those models and scenarios, data acquisition, data displayed, visualization, and such. So where the water managers and our partners, Army Corps of Engineers partners, are some of the local agencies, water agencies, and also with the National Weather Service folks. And we use those as part of our daily duty to provide this information. And second is to disseminate consistent and timely delivery of the water management information to public. Specifically, we're talking about hydrologic time series data sets. And the last but not the least, they provide the valuable information to the senior leadership at all levels, at the district leadership level, at the division leadership, and the headquarters level. So all of that will be combined. The data would be coming into in a vertical teaming arrangement. So in terms of, Tom mentioned about IRIS, and this is, we have a partnership with our organizations, USGS and National Weather Service is predominantly under the charter, and we have this information, we call it a charter called System Inoperability and Data Synchronization Charter, and also Jerad mentioned before was flood inundation mapping as well. So particularly in this context of data exchange among the agencies, federal agencies, is very critical for us, and that we learned the lesson that actually came from 2010 flood from Nashville. So that's where we have collaborated it, and we determined the agency requirements in FY13, delivered a complete requirement document in 14, and we continue to do the work in design teams will be worked on, and we will have an expected delivery of the work products in 2015. In terms of open water data, we see we have a challenge to disseminate large amounts of hydrologic time series data upstream and downstream of our reservoirs. The second part is also important for us, which we should be letting you know that we will not be able to release some of the data which are sensitive. And so those data sets could not be released for security reasons. And this is a map which shows us where we have the storage and the stage data set and stream gauging data available in the country, and it says about 2,900 gauges are where the data should be available from our system. With that, I appreciate David for your invitation.
Thank you so much, Chandra. And one of the things that I got out of interacting with the Corps on this is that at the Weather Service is sort of this national perspective, but you can see there's a strong regional perspective with the Corps of Engineers. And when it comes to the local emergency response, there's a local perspective. So we've got to go national, regional, local, and it's all got to fit together. That's one of the challenges of this whole process here. So to complete our speaker set today, I'm going to introduce Joe Nimmich, who's now the Deputy Administrator of FEMA. He was confirmed by the Senate on September of 2014 in that position. And in that capacity, he is responsible for response, recovery, and the logistics offices of FEMA. And he's also the director of the Federal Office, or the FEMA Office of Federal Disaster Coordination. And in fact, we had a meeting with Mr. Nimmich and Administrator Fugate in the, what's it called, the Coordination Centre, right? Yeah, the National Response Coordination Centre at the FEMA headquarters, where the President is briefed when there's a national disaster, and so Mr. Nimmich is responsible for that. He was 33 years in the Coast Guard before he retired, and I always say, 10 hut officer on deck when you... I've seen A Few Good Men 30 times. I don't know if you know that movie. Yeah. 10 hut officer on deck. Yeah. I feel like I should straighten my back a bit, He retired as a Rear Admiral, and he was a 1977 graduate of the US Coast Guard Academy. He has an MBA from the Stern School of Business and an MS in Strategic Studies from the US Army War College. So thank you very much, Mr. Nimmich.
Could you put up your first slide, the slide you introduced? Thank you. Well, thank you very much, David, for the invitation. And I asked to have this slide put back up because if you take a look at it, it all ends with FEMA. And that's true because FEMA is the one who interfaces with the American public when things don't go well. And a lot of what you're talking about is how do we understand, how do we use the data, how do we predict things, and how do we know how things are going to react. I want to thank you all for the opportunity and to thank the Water Resource Association for their 50 years of driving meaningful dialogue in the area of water. I'm probably speaking to the wrong group this morning when it comes to water and what water means. Most of the country probably doesn't understand the impact that water and our ability to understand water has. Certainly the folks in California do now as a result of a lack of water. But across the board, water causes more damage and has more disasters than any other natural affecting element that we deal with in FEMA. More people die annually from flooding than from any other natural hazard. Give you an idea of what it looks like over the past 10 years. True flooding events, like you've heard Tom talk about, Nashville and others, there's been 64. There's been 71 hurricanes that affected the United States. There's been 3 tsunamis and 4 typhoons, and 463 severe storms that have been declared national disasters. 463 storms. Water isn't just those big items that we see, those ones that we hear about. It is every day there is a disaster in this country that we're dealing with in terms of what the damage water has done because of our inability to take all of the data and be able to either design for the future or to at least predict the impacts it's going to have. So I'm going to talk a little bit about the use cases that Tom talked about. I want to bring up one now, and we'll come back to it several times during the discussion. The use case is currently we're dealing with a disaster in Michigan around Detroit. Anybody aware of the flooding that occurred in Detroit? Okay, a few people are. It was a rainstorm, 5 inches of rain in the Detroit area. We've had 92,000 people register, 58,000 have qualified for FEMA support, and that's over $100 million going out to individuals for a 5-inch rainstorm. Colorado, last September, a year ago September, had an entire year's worth of rain in 3 days. The town of Jonestown, up in the mountains, has dealt with record snowstorms, has dealt with wildfires, has dealt with all sorts of natural disasters, and was wiped out as a result. This is a town that had a creek flowing through it that existed at about 7,000 feet. Never in their wildest imaginations did they think a flood would take their town out. But yet the creek moved and took out, it's only about 100 homes, damaged or destroyed the infrastructure for over 60% of those homes. Water is, in fact, the biggest challenge we have when it comes to natural disasters. The National Hurricane Center came into play in the before Andrew. And what was all the predictions that we looked at the Hurricane Center? What's the wind going to do? How much wind is there? We define the size of a hurricane based on its wind, and yet what happened in New York and New Jersey with Sandy? Not a single structure was damaged by wind. It's a $60 billion destruction damage in New York City, the New Jersey coast, and the Long Island coast. It's all about water. It's all about surge. We are just now having the National Hurricane Center. They tested the surge model this year, but it still isn't gone live. Next year, we're hoping that it goes live to get people to understand what the impacts are likely to be. Hurricane Katrina, we lost over 1,100 people, mostly due to flooding and then couldn't get away from the flooding effect. In Hurricane Sandy, less than 110 people died because people understood how to evacuate. They knew when they were in a flood zone. It is all about the water. I'm preaching to the wrong group of people here. And the water's changing dramatically as a result of climate. You've heard that. Back in August on Long Island, Islip, Long Island had 14 inches of rain in less than 2 hours. 14 inches of rain in less than 2 hours. Pensacola had over 20 inches of rain in 24 hours, and it was not a tropical event. It was back in April. It was before the hurricane scene. It was just a front going through. 20 inches of rain in 24 hours. We in FEMA try to address this through multiple different functions, as you may be aware. We do a lot, and the difference between Katrina and Sandy is a lot of the preparations we do, the preparedness of getting people to understand the impacts that they have. Ready.gov helps people understand how to be prepared. But we do an awful lot more than that at FEMA. The National Flood Insurance Program. Over $42 billion has been distributed in that program since its inception. We can argue today whether that's a good program or a bad program. We're actually supplementing risk that people take. There's been more building in floodplains as a result of the ability to get insurance than there would have been if you didn't have insurance. Multiple claims, tremendous amounts of issues that we need to deal with based on the data that you provide in order to understand how are we going to address mitigation strategies in terms of construction, and how are we going to address the ability to place risk where risk needs to be placed to try to change people's behaviors. The third one is that we deal with is a mitigation strategy. Whenever FEMA rebuilds, we try to rebuild based on the current technology, based on the best data you provide us. So an awful lot of what we learned in Hurricane Irene and the floods in Colorado is to not build back the culverts the same size they were built before. Most culverts are designed based on what history has told us. It is critical for you to be telling us what the future looks like so we can build culverts that don't mean the roads have to be repaired every time that there's a rain event. In North Dakota, I pay for every time there's a rain event, I pay about $1 million to be able to go back and regrade their roads because we don't change the culverts because I can't get that into the mitigation strategy. We need to be getting better data that I don't look at what happened in the past, but I look at what the future brings. You know that this administration has been heavily focused on climate adaptation. I get to go from here to the interagency climate resilience meeting at the White House, where FEMA is probably going to be directed to coordinate the interagency to do this. I'm not sure we're the right ones, but that's probably where it's going to reside, because we, at the end of the day, are the ones that deal with most of the problems. And we continue to look at the business case in terms of a cost-benefit analysis by looking in the rearview mirror rather than looking at the data you all can provide us in terms of what's coming. The Open Water Data Initiative is an extraordinarily critical one for us, and that's why I'm here today. This type of architecture will help all of us, particularly the stakeholders, not just in the federal government, but at the state and local levels, and even down to the individuals, to be able to better address the needs and be able to face the future in terms of what water can do for us and to us. Most of our models are out of date. Most of the data that our models need is collected in antiquated ways. And in fact, we don't do what Dr. Sullivan talked about, which is environmental intelligence. If you look at what the intelligence community can do in preparation for virtually any defense decision, and then how we create that back into terms of the environmental intelligence we get, we're in the dark ages. We just don't use the information, the power of computing, and the ability to develop accurate models down to what David's going to talk about it for us, down to the individual level. How many people here have gotten on their phones an alert warning for flash flooding in their area? And what do? You turn it off. And why do you turn it off? Because we cover an entire county or a state, and the flash flood is extraordinarily localized. We have the technology to be able to get down to that localized notification. We have, through USGS and others, the topography to be able to tell us where we're going to really have a problem. And yet we deal with these large areas, so what happens is we ignore it. And then because we ignore it, people go up to a flooded area, and like a poor gentleman in the last time in Texas, and David, I think it was in the Austin one, tries to drive through 4 feet of standing or moving water, and when they rescue him, and they pull him out and they say, why did you go through it? Well, this is the only way I know how to get home from here. How did we stop him before he got there? How did we use technology today to interface with the lighting, the traffic lights, to be able to stop him before he even got to where he couldn't make a decision to turn around and go some other direction? How do we prevent that? I spent 33 years trying to overcome Darwin in the search and rescue program in the Coast Guard, because most of the people I saved put themselves in harm's way. We continue to do that now in terms of we invest a lot in fast water rescues. We invest a lot in the helicopters to be able to pull people out of these situations they get themselves into, and we underinvest in being able to prevent them from getting there in the first place. If you go to Phoenix, Arizona, they know when you get 2 inches of rain, every road that's going to be flooded. And yet there are no barriers put down like you do for train crossings. That when they know, based on predicted rain, and at a certain point based on a gauge, they could activate these and put them down to prevent people from going across standing water or moving water. It's a lot less expensive than continuing to train and have other first responders put themselves and their lives at risk. So why am I here today? I'm here today to tell you that I am both a consumer and a provider of information. Through our National Flood Insurance Program, we develop Risk Map. A lot of you provide information to Risk Map. We are continuing to try to develop that in a way that allows us to use the best information available. But often Risk Map and the flood plain mapping is a long, laborious, politically driven process. We wind up with an awful lot of pressure put upon us because when we say somebody's in a floodplain, that means the house might not get sold. It means that the developer may not be able to bring new jobs to that community. And I will tell you, communities are constantly struggling with today to the future. And more often than not, today wins. That developer who says, if we can just get out of this floodplain, I can bring you in X jobs and X number of new residents, weighs heavily on those boards, those county commissioners, when they're trying to decide how they're going to get through the next year and what their tax base is going to look like. This is a challenge for all of us, and the only way we overcome it is with the best data that you all provide. I look at it from multiple ways. Right before, floodplain mapping. I look at it long-term before with floodplain mapping. Right before, in terms of early warning systems. I should have been able, and I'm going to go back to Detroit and what they're facing now, I should have been able to know that I was going to have a disaster there before and while it was occurring. The topography, everything is there to tell me. The information's there. We don't put it together. So when I was dealing with the Arkansas tornadoes earlier this year, within 24 hours I could tell the amount of damage that was there and the ability to tell that community that we would create an individual assistance disaster and start getting them resources. It took me 45 days before we declared a declaration in Michigan. 45 days that people didn't know if they were going to get support or not. Probably people who needed support as much, if not more, than the folks in Arkansas. Because I didn't have flood data to tell me how many houses were likely inundated, how high the data. So I had to go house to house to house until we got the numbers, and I had to send out building inspectors to look at it. I should be able to use the data you provide in a predictive manner to be able to tell me, I know at least this much damage is going to occur. I should be able to predict the damage that flood causes in areas. During the disaster, I should be able to tell people the routes they can go and the routes they can't go, when to get out, when not to get out. The more often I give requirements to vacate or to leave an area due to potential flooding and it doesn't flood, the more people start doubting what our capability is and the more they're not likely to evacuate. I have to maintain credibility and I have to be able to do it better. And then certainly after, as I just talked about, I should be able to predict the extent of damage based on water down to a stream almost immediately after that event, or base predictive on the excellent work that we're getting from the National Weather Service. The rain amounts they tell us are as accurate as they have ever been, and they continue to get better. They can tell the amount of rain we're going to have by looking at the size and the reflectivity they get out of the cloud base. They know how much water is coming down. They aren't wrong very often. As policymakers, we need to continue to shape our programs and look forward to how we're going to use the data that's available and how we're going to share it. As I said, we've been flood mapping for 45 years. I don't know how many of you use our flood maps or how many of you have access to the data. We want to be a member of IRIS. We want to be able to continue to provide data, but data is always a backward look. What are the projections? What are the models telling us? How do we get better models? I think I saw one of the discussions you're going to have is the 80s want their models back. If that isn't an accurate statement about where we are in terms of it, we have huge computing capability now. We got to make the models match the computing capability that we've got. So this is going to lead to my final note. We in FEMA can't do it alone. Everything we do is partnerships. When there's a disaster, FEMA brings virtually no resources to a disaster. We have the ability to coordinate across the federal government. It takes the whole community approach, from the individual to the local community, to the county, to the state, to the federal government if we're going to make a difference. And the only way we can make a difference is if we're all looking at the same information and have the same understanding of what that information tells us. The National Flood Interoperability Experiment that David's running is a critical factor of how we do this. It looks at local community sensors. How do they interact with Corps of Engineers information, with the National Weather Service's predictive capability, with the topography that we know we get from the USGS? How does all of this come together to allow those people at the end who make the decision, those first responders and the individuals, have a good sense of what's going on? And then how do we get that information outside of our systems onto what you saw in that picture of the Pope over 8 years? We are all carrying them. We can't put out information that makes us ignore what's on there. We've got to get it down to the level where it's valuable to us. Till that time comes, FEMA will continue to put in the extraordinary amount of effort and cost in risk maps. These are sources of information that we intend to work with David on and provide that information to the extent we can. Anywhere that we're told that we can't provide the information, we should be looking at how we get that information out, how do we put it together, and how do we create the cloud environment that all of this comes together and we can truly, and I really do appreciate Dr. Sullivan's term, create environmental intelligence. That's what we're looking for. We have great intelligence capability. I would argue that some of the models that we use in the intelligence community for national security probably have applications here, and I'm very comfortable saying that the implications here are as big and have as strong an impact as does our national security intelligence program. So I thank you for the opportunity. We are going to be a partner in the National Water Center. How well that comes together and how well we can influence it. We were down there just this past September to talk about how our flood insurance program, the risk map, the flood inundation mapping processes might better be located there than in D.C. That's a small staff. All the contractors, and we pay a lot of money to a lot of people to help us do that. We don't do that internally. We oversee the program. But some of that, when you got the best hydrologists there, the best opportunity to look at it, and quite frankly, Tom, the ability to use your operations center in a more constructive way are hugely interested to us. So we're going to be a partner in IRIS because I need to be, because at the end of the day on that chart, it all comes down to how do we interact with the public and how do we get the public to understand and respond the way they need to. So I want to thank you for the opportunity, David, and I look forward to your questions.
Thank you very much, Joe. And I have to say that the vision that I described for the National Flood Interoperability Experiment didn't come from me originally. It came actually from Craig Fugate, who's the administrator of FEMA. And so he'd been talking with Jack Dangerman for more than a year, and Jack had been sending me these messages like, we need to go, can we do that? And I, yeah, well, yes, Jack, but not yet. Wait, we're not ready yet. And then when this National Water Centre thing came up, I thought, okay, now's the time. So, that email that I sent wasn't just coming from me alone, and I've been thinking about this already for more than a year. And I have to say, it was the drivers that you just heard about that caused me to present what I did. And I didn't say it was from FEMA, right, or from Fugate. And I just said, here's what we need to do. But that was why I formulated it that way. I don't think I would have had the courage to do that on my own, frankly. Before we begin the discussion, I want to introduce some of the leadership that actually gets things done. This is the leadership that directs what should be done. One of them is Ed Clark here. Ed, this is Ed, is the co-chair of the Subcommittee on Spatial Water Data, and he's my co-leader with on the National Flood Interoperability Experiment with the Weather Service. And Al Ray, is Al here? Yeah, okay, yeah, so here's Al. Al is the other co-chair of the National Subcommittee on Spatial Water Data. He deals with the geospatial side of it, and Ed's doing more with the temporal side. And I want to introduce Dwayne Young. Where's Dwayne? I saw him. Yeah, here's Dwayne Young. So we've had the sort of the physical side of the water resources community here, but Dwayne's really a leader in the water quality side, and EPA gets involved in floods too because, well, lots of environmental damage happens in floods. Tanks leak, stuff goes down rivers and so on. So besides the physical agencies that you've been hearing about, the EPA is also one of the key players, and Dwayne's the lead person for them for open water data. So with that, let me just open up the discussion here. This is the national leadership, so what have you got to say to them? Yes, sir.
Noel Gallon, Natural Resources Conservation Service.
Mm-hmm.
I have a little problem with your little schematic.
Uh-huh.
I see Jerad smiling. He knows what I'm going to say.
Good.
Last time I checked, it just didn't rain in the river.
Uh-huh.
It rains on the uplands. It rains on the soil. And that runoff factor that occurs at that level between the atmosphere and the river can really influence what you find down on that bottom corner.
Mm-hmm.
And I see it's missing there.
Yeah. Well, frankly, we would love to work more closely with the Natural Resource Conservation Service, and I've been pursuing you for years. So, yes, come on in. I was in Portland at the Weather and Climate Centre recently, and I met with the people in Fort Worth, and, yeah, we really want to work with NRCS for sure. Any other questions and comments? Yes.
So I'm a local practitioner.
professional engineer that works with local governments, state governments, and the like, dealing with flooding and other resource issues. You know, this is great. I mean, it sounds good and everything. There's always a but. And one of the questions I have for you is, we can already gather these data efficiently if there's web services that are stable. But there seems to be a lack of focus in the federal agencies on web services and making sure that they're stable through time. How does that fit into this effort? Making sure that web services are there, they work, there's a data standard associated with them, and people can get to the data. And as soon as I build an application, someone doesn't change it the next day.
Jerad, that sounds like a Jerad question.
It's interesting. As you were talking, I saw a bunch of heads nodding. So it must be an issue. It's clearly, if we don't have stable web services, then the whole thing falls apart. I mean, our vision at USGS and I think more broadly among the partners is that web services, as I said in my talk, is the way to go. That, you know, you don't have to go look for the latest data set. The data set comes to you. Now, the stability issue, I guess I wasn't aware of it, and I would be interested to hear more about it from you. You know, is it that there's a change in address, a change in data formatting, and so on? But I think data standardization is clearly a part of what we're trying to do, so that data, hydrologic data from the Corps of Engineers and from USGS and from FEMA and the Weather Service and other folks that want to partner, that it all looks the same. It looks the same to the computer.
As a follow-up question, you're kind of off the hook there, because the GS is actually quite good at it.
Thank you.
Mentioned that, but I would actually challenge the thought that all of the data has to look the same. If it's a daily time series of stream flows or some other type of data, what I would suggest is that data standard has to be known and it has to be stable. They don't have to look the same.
No, I mean, I guess what I meant look the same was they don't look the same coming in, but they look the same going out. Right.
Dave, do you want to comment on that? I mean, you're a data geek here. The USGS is really the anchor of this in the US, and this is Dave Blodgett from the Wisconsin Center. Can you say something about the OGC process? Because we put a lot of effort into standardization here.
Yeah, I think one of the central tendencies for this Open Water Data Initiative is going to be identification of stable specifications and versioned web service specifications that allow us to offer the kind of stability that people really expect when they invest in software. And you know, the OGC is one of the clear leaders in that realm of you know, documented version specifications for web available information. And there at OGC, and there are other places we will look for you know, those ways we advertise and provide our information.
And what we're doing with the National Flood Interoperability Experiment is we're trying to develop a common information model for flood response, which is based on those standards, and it deals not just with this time series, but where they're measured and things like that, and the inundation mapping and such. Yes, Alva.
I'm Alva Couch from Quasi. The big issue here, I think, is not a technical problem, but a money problem. What I see is that people don't budget for keeping up with standards, for evolving, for leaving old services up because there are actually clients of them. I'm not going to be taking my old services down even when I put up my OGC standard services, which I'm doing in the immediate future, because we have a client base and we have to be sensitive to that client base. What that means is that there has to be a life cycle management on services, and it's not the technical issue that is important, it is the money issue, because I have had a lot of cases in which not enough money was budgeted to keep things up to date and to keep things working. And so I think that in general, especially over the realm of private services for scientists, this is true. But it's also true to a certain extent at the government level. Life cycle management is important. The various issues of life cycle management include keeping old services up so that we don't drop users on the floor, and putting up the new world standards as they come up in parallel.
Okay, thank you. More questions or comments? Yes.
Yeah, I have a question about, and it's a little similar to Noel's, about drought. Maybe this is focused on flooding right now because it's the beginning of this process. But I heard through a colleague that one of FEMA officials, something that kept him up at night was actually drought, and especially drought for major cities. A colleague and I just put out just a little simple two-pager on drought and municipal supply. Do you intend to extend this to, say, reclamation, in particular in the West? I noticed on the map, one of the forest maps, there's a big gap there in the Central Valley from Shasta almost down on the sites monitored for that system. And I think reclamation would fill some of that data gap.
Let me call on Angela Adams, who's from Reclamation, to respond to that.
So thanks for asking that question. And in fact, I'd kind of like to talk to you a little bit during the break or later. One of the projects or pilot projects in the Open Water Data Initiative is to look at water supply. And I work with Reclamation, so we're taking the lead on that. And in fact, the Department of Interior is very interested in putting together some sort of a predictive analysis tool that involves water supply. As you know, we've been involved with the Colorado River Basin study, and so the potential area of focus for that portion of the OWDI activity is the Colorado River Basin. So yes, we're involved. Yes, we're interested, and there are some activities.
And we have.
If I could follow on, that FEMA official is Craig Fugate, and it has to do with what keeps him up. Craig is pretty good study of history of disasters and how disasters, and he will be the first one to tell you that entire cities have disappeared as a result of drought, but never as a result of flood. So that you really do face a very unique challenge. And his big fear is we know that the climate's changing. We know that there are going to be parts of this country that go into even more extended droughts than we've had to date. And how do we plan on dealing with that? Because the ability to move water is not a very easy thing to do. His contention that it comes down to is we have undervalued water both in the excess and in the restriction of the amount. We don't pay for what water really is valuable.
And I'd like to add to that a brief, the current modeling infrastructure we have right now in the Weather Service is really, it's geared toward flood forecasting. And what we're looking at with the implementation of this national water model at the NHD plus scale is really looking at the full gamut of the hydrologic cycle. I mean, really floods to droughts. So it's not only just high flows, but low flows, because those are obviously increasingly becoming an issue for this country. And a lot of the issues that keep people up at night are as much or more associated with low flow as high flow. So.
We've talked about if this flood experiment is successful, next year flipping it over and having a national drought interoperability experiment. Same idea, but for the low flow side.
David, maybe I want to add a couple of points in here from 2012 drought specifically. We had a lot of push from our stakeholders to give up the flood space during the flood season. And one of the issues we constantly battle with is during the flood season when there are no rains coming, the problem remains that we need to keep that flood space open because majority, if you go back and look at the historical data, droughts are always busted by the floods, majority of the times. So when you give up and you do not know when they're coming, they don't, so that becomes a very challenging work for us to look at the predictions, the hydrologic as well as what you call rainfall predictions during for 30 days, 60 days, and 90 days, and that becomes an issue because you say, do you know is going to be when it's going to be busted, so we can allow the water to. So we are under tremendous pressure to give up the flood space, and we have and we always are in this bind. And one of the things, as I pointed out, that we need to go back to the Congress if we need to make a revision or change to that congressionally authorized purpose for that particular project. And that's the way we normally do. So we are kind of sandwiched in between those two issues we have to follow what's congressionally authorized. We cannot give up the space unless Congress tells us so. So we are always having this debate, and that becomes enormous when we have no new water supply facilities are coming online. Specifically, like California has come up with $2+ billion for a new infrastructure building to alleviate this water supply issue. So we are trying to manage. The other issue we are always looking at is how can the forecast, near real forecast, could be improved to see how we can do water management better. Actually, we are doing so, and we are still looking in the possibility of, example, Folsom Dam. We are doing some pilot studies in that regard. So we are constantly looking to do things better if possible with the new technology.
Yeah, the Folsom case is one that's annually, there's a lot of pressure to change that.
Thank you.
Great, thank you.
Okay, we're getting near the end here. 3 more questions, and then I think we'll be done. Yes.
Yes, thanks, David. Jack from NOAA, and I want to make the panel members and others aware of some recent activity that's relevant to the question about web services here. I'm co-chairing a group, which is the U.S. Group on Earth Observations Data Management Working Group, and we've been talking about the standards that should be used to establish what we're calling a Earth Observations Common Framework, i.e. the services and standards you'd want to use to enable data discovery, data access, good data documentation, i.e. metadata, compatible formats, and vocabularies. I know some of the things we're talking about are exactly some of the ones you're talking about, David, including obviously OGC services as well as OpenDAP and other services and standards. So I'd like to let you know about that. It is a interagency federal group open to feds right now, so we don't have a document that we can send out more publicly, but I'd certainly like the agencies here to know about it. You do have representatives, actually, except for FEMA, on the group. Not sure, you could have other ones. I'm not sure they're exactly the right ones. I mean, I'm not saying they're wrong, but it would be nice to have people specifically involved in this, flood interoperability experiment also on that.
Thank you, Jeff. Any more comments or thoughts? Yes, Dan.
Good question for Thomas about the water center. So it sounds like there's some pretty good infusion of money starting it. What's the long-term prognosis? How will it be funded? And who's expected to occupy that space? Is it federal agencies will send staff in there, or will it be academics in there? What's the plan?
The plan is, as I mentioned for IOC anyway, the first 50 or so people will be a combination of NOAA, federal, USGS, FEMA, visiting scientists, a few contractors. In time, we weren't resourced to staff up to 200 yet. We're in the process of at least assuming getting this initial operating capability, and then looking to other federal agencies across NOAA, other lines in NOAA that would be suitable and appropriate to staff the facility. It's essentially sort of a field of dreams, if you will, sort of build it and they will come. We've got to, initially populate it. We need to demonstrate a capability that we can be successful, that we're moving the whole prediction capability forward, and then train in the broader enterprise to hopefully participate more closely and perhaps even take residence in the facility. So,
Senator Shelby's on the Senate Appropriations Committee, and Republicans just became majority in the Senate, so that might help too. Any other questions and thoughts? Yes.
A question for Joseph Nimmich. I'm curious about your comments on moving from data to true environmental intelligence, and specifically your comment about the national security intelligence community and how the water community might be able to use some of the techniques and methods that are applied there. Can you say anything more about that?
I think it's just more of a comparison that we've invested a huge amount of money in being able to access data, access information, and then have analytic tools that allow people to make very quick decisions in the intelligence community. There should be no reason we can't do the same thing. The computing power is there. What we've invested in the National Weather Service and others in terms of the computing capability, it's really how do we get to that access. Most of the intelligence community has all been about access, some of which we may agree with here, some of which we may disagree with here, but it's all about access to information. I think that's the biggest challenge we've got, and why you are so critical to this is the ability to identify where information exists that we may not have accessed before, and how do we apply that. The more information, the more data you get, the more you need computing capability in order to be able to make real knowledge or intelligence out of that. That was my comparison. I don't know that there's specific programs per se that would be applicable. It's more just the understanding that we've invested there, we get real value there. We need to do the same here.
Okay, thank you very much, everybody, and let's give the speakers a round of applause.